Hi everyone, and thank you for joining our call today. Today we'll have a presentation on RGB roadmap, and Maxim, just go ahead and start.
Yeah, thank you. We've been talking about RGB for a long time, and we got also a lot of questions. So today we decided we now much more clear where we are and how much of the work is left. So we decided to do a special session about RGB roadmap, where we will describe what we have today, what we might consider an RGB release, when it may happen, and what would be the roadmap ahead. And additionally to that, while I'll be talking about the roadmap for different RGB components, including past components, I will be doing small intermediates about specific applications using RGB or specific aspects of the protocol in the parts where we got most of the questions over the last weeks. So I will begin with the vision, which precedes the current implementation and current incarnation of RGB. And that vision was that with a Bitcoin and Lightning Network, what we call LNPBP stack, multiplied by the thing called client-side validation, when you put the data off-chain, it is possible to do everything which was promised by Ethereum or other next generation blockchain smart contracting system, but was never delivered in a scalable and censorship way. And we believe that with LNPBP technology and client-side validation, it is possible to do all of those applications that were eventually possible, of course, not from the very beginning, but it's like long-term vision. All those applications and decentralized things which can't be done just by using blockchain without Lightning Network and without moving to client-side validation. And of course, all of that has to be done within Bitcoin ecosystem without inventing new tokens or coins or blockchains or forks of Bitcoin itself. So that is the vision. And this vision led us to RGB, which today we call a smart contracts for LNPBP stack. And there is 4 key properties of RGB smart contracts. First of all, these smart contracts are about bearer rights contracts. So the ownership of the state, it could be assets, it could be non-fungible assets, it could be very complex forms of smart contracts, but everything is up to a state, and the ownership of the state is not stored in some sort of registry like blockchain, because blockchain is also a sort of registry, but it is stored by the client. That's why we call this client-side validation. And in fact, the RGB is a digital representation of the centralized bearer rights system as it existed before the centralization of financial world, which preceded even the abolishment of gold standard. So additionally to Bitcoin solving the problem of money, RGB smart contracts in this regard can solve the problem of today world financial contracts, which are not bearer rights anymore and always kept in sort of centralized registries, while you need to get a SEC approval for doing IPO or issuing bonds and so on and so forth. So with RGB, you don't need that anymore. The second key property is the confidentiality. And we tried to bring this confidentiality to extreme. We were able to do that partially because we are using client-side validation, meaning that we got security through obscurity when nobody in the world knows the existence of certain form of the smart contract just because it's not published to any registry and just kept by the participants of the smart contract having incentive not to make it public. But additionally to that, RGB, it's not enough. Of course, security by obscurity is not enough. So RGB uses zero-knowledge things like Pedersen commitment with bulletproofs for everything that can be represented as integers. And it also uses a lot of merkleization that allows you to hide many parts of the smart contract that are not needed to be known by certain participants. Third property of RGB is the fact that these contracts are scalable. And the scalability comes to the two main factors. The first factor is that we do not store information in blockchain. And as we know, blockchain does not scale, at least as a storage medium. So this why by not putting information into blockchain, but not putting the data into blockchain, we are able to avoid the limitation of blockchain scalability. However, we since need to create transactions to we still use blockchain, Bitcoin blockchain specifically as a final card, like Lightning Network does. But here we achieve scalability, the second form of scalability, by the fact that we are able to work on top of the Lightning Network. So we have storage scalability because of client-side validation, and we have a transaction through output scalability because of ability to reuse Lightning Network and to put most of the updates to the smart contract system to be part of the Lightning Network state channel. For that reason, we also need to extend the Lightning Network itself into what we call LNP, Lightning Network Protocol, which fully includes existing Lightning Network, but provides a lot of stuff on top. And today, when I will be talking about the roadmap for that improvements, I will be giving much more insights about which specific improvements we need and how they will be organized. So additionally to the roadmap, we will have these technical details of these improvements. Specifically, these improvements are highly important for unlocking such functionality, which is called DeFi, the term which we do not like. I think that the idea of making finance world decentralized and able to operate outside of the scope of global regulators and also blockchain environment is crucial. But probably we should call it not DeFi, but BFi, like Bitcoin finance or something like that, just to avoid this association with the token systems and with the systems that do it in a proper way. But anyway, I'm going into a bit off topic. But what I was going to say that these improvements to the Lightning Network we are developing is crucial to doing stuff like decentralized exchanges or liquidity pools or even stable coins, algorithmical stable coins. These topics will be covered in this presentation briefly, and we will devote a special presentation to this topic in the future, maybe in 2 weeks from now, the next call. And finally, the fourth property of RGB is the fact that this system is a layer for Bitcoin programmability. Finally, by putting together Lightning Network, core Bitcoin blockchain, and RGB on top of it, we are able to make Bitcoin programmable with a proper risk separation, not getting into the same trap as Ethereum and many other blockchain projects did when we put and mix everything into the same level, and we got no scalability, no confidentiality, centralization at the level of registry, and we got programmability with a lot of hacks. Here, by separating layers, we got all these properties, and hopefully this will work much better. So we think that the proper smart contract system in LNPBP should consist of 2 or 3 components which are easily composable together, and indeed they are composed as today is within the RGB. These 3 components are, first of all, Bitcoin script, which exists inside Bitcoin blockchain and Bitcoin transactions. It doesn't go anywhere. It is proven for more than 10 years of usage. And Bitcoin script should be used to control the ownership of Bitcoins, of course, ownership of certain data, ownership of certain assets, and generic state. So Bitcoin script used not just at the level of Bitcoin itself, but also by RGB, not on the client-side validated data, but as a part of Bitcoin transaction, which is also analyzed and verified by RGB itself. The second thing that is important for proper smart contract system is a scriptless script concept created by Blockstream researchers, including Andrew Belstra and others, And this type of solutions, like discrete log contracts, which can be used for creating future forms of contracts over the Bitcoin and Lightning Network, they're also very important. And basically, it's an extension of Bitcoin scripting system, which is also well composable with RGB itself. And finally, RGB as a smart contracting layer should be used in the more complex scenarios, which you can't cover just with a Bitcoin script or scriptless script, when you have a richer state or more complex forms of validations, which can be implemented with a Bitcoin script or scriptless scripts. And here where RGB with this client-side validation come to help. So putting all these three together, we get the fulfillment of the base layer for this grand vision, which I was talking at the beginning of my presentation. The RGB smart contracts made this way are quite different to existing ecosystems of smart contracts. They do not have any utility token. They operate just money, Bitcoin and Bitcoin over Lightning. Of course, they allow you to issue tokens or to create different forms of financial contracts or assets, but RGB as a system itself doesn't require any of those to be operational, just Bitcoin and Bitcoin over Lightning. And you can make very advanced stuff with that without introducing new tokens. Most of the smart contracts can be implemented without new tokens just by using Bitcoin. The second is that we're not trying to create a new consensus layer. We're not trying to do a new blockchain. We're just using the best censorship-resistant consensus we have today. Proof of work, which is the only censorship-resistant consensus by its design, because you can't get censorship resistance from pure proof of stake. And the proof of work of Bitcoin blockchain, because it has highest hash rate, and thus the highest security today. Third, we use declarative and functional forms of defining business logic, trying to avoid EVM type or WASM type mistakes. We have a special dedicated virtual machine called Illuvium, which is a functional virtual machine, having no memory access, no operations for memory access, always having no exceptions, and so on and so forth. We do not have any global state. Unlike the smart contracting system, this unlocks a lot of scalability and a lot on confidentiality, because nobody in the world can know the global state of the smart contract. It's just technically impossible. So chain analysis and more advanced forms of analysis, even if the client-side validation data leaked, are still not possible at global scale. And finally, the contracts are fully isolated from each other. So there is no RGB network. There is no RGB system as a whole. There is a protocol as an agreement between different participants, and there are contracts which are completely isolated from one another. They don't know nothing about the existence of other contracts. They can't talk to each other. And basically, you may think about each RGB smart contract as a shard. So RGB smart contracts sharded from the day one. And this sharding is not that kind of sharding you get from Ethereum, where you still have to make the shards interact, which actually is quite unresolvable task in terms of computer science. Here, because shards do not interact, they don't need to be even eventually synchronous. We have quite scalable system with this isolation of state of one contract from the another. So to answer the question how we are far from the release of RGB today, I will start with a background and go through the history of RGB development, highlighting certain important components. And we will go to the definition of what can be considered our RGB release and what we will have ahead of that. The RGB has started in 2016. It wasn't thought RGB those days. It was just works of Peter Todd, who created the concepts of client-side validation and a single-use seals, which are basically a security model for building client-side validation applications, as an extension of his own work and previous creation of open timestamps. This idea was taken by Giacomo Zucco, who envisioned that this concept can be applicable to make a proper protocol for fungible assets, which will be a better alternative to other protocols like Omni layer or colored coins. And actually, Giacomo was the first who thought about the composition of Bitcoin and Lightning Network stack into LNPBP stack, and that such protocol may work on top of both Lightning and Bitcoin network. They did a first proof of concept with Alikos Fellini. It was quite an early concept because it was only theoretically supporting Lightning Network, and it was created for a single asset world paradigm. But nevertheless, it was Giacomo who created the term RGB and who envisioned the potential application for financial assets. I joined the project in 2019 and leading the development of it since that time. And my main work throughout this time will extend the protocol for real-world applications, like allowing complex scenarios with multiple assets coexisting in the same Bitcoin transaction, and adding more zero knowledge, designing the Lightning part of the implementation, and adding virtual machine, and doing everything that is necessary to convert RGB from just better colored coin or Omni protocol into a fully fledged smart contract system, which we are nearly finally achieving these days. And throughout all of these milestones, there were no single ICO or ICO temp token issuance, and all the protocols and standards and reference implementation of all the standards are fully open source under Creative Commons, MIT, or Apache 2 license. They are available, and you can run the whole RGB stack even today with the beta versions of RGB without relying on any commercial entity or anything closed source. Today, RGB development and finalization is led by LNPBP Standards Association. This is a non-profit Swiss-based, not an organization, because in Switzerland we enjoy a very nice feature of having association as a legal entity established by just a signature of two or more people without any formal governmental registration. We just don't need even to inform the government about the creation of entity. It's just a paper signed by participants of the association. And that's all. It's a form of bearer right organization, basically. And me and Giacomo, we did created this association to envision, to oversee the development of RGB protocol, not to be put into any intellectual property rights of any company or for profit in 2019. Today, we have more than 25 contributors to standards and source code. We have wrote more than 1 million of lines of Rust code, which was a hard deal. It took most of the last 2 years of my time. And many of that code, if not most of it, like more than 50% of it, went to the lower level Bitcoin and Lightning Network libraries, Rust libraries, which had to be improved and enriched in functionality in order to support everything that we need at the level of RGB. And today we already know that a couple of companies working together and separately even on the development of for-profit products. It's my own company, Pandora Core, which does their products as a layer on top of RGB, and these products are also open source. Condensate technology, Nodal, HODL, change a blockchain of things, and probably others which we don't even know that they are working on some products based on RGB. It is still early days, so before the RGB release, it is not advised to integrate it into your products, because we may have, and we constantly have, a breaking API changes which actually force developers to implement the integration layer. But as I will be showing, we will have the release in the following months So that would be proper time for companies to start considering using RGB in their products. Recklessly, of course, because there is no guarantee that there will be no bugs discovered and there will be no security issues, but at least you may be sure that the API wouldn't change. Let's start with the road mapping, all of the RGB functionality. And for roadmap, I will use the same legend. I will talk about it in just few words, just for you to better understand what is shown on this schemata. The color encoding signifies the completion of certain components. So on the right side, you see like 3 example components, and the arrow shows dependency between components. So you have to fully complete the first component before you will be able to fully complete the second component. Of course, some parts can be developed independently still, but the full completion requires the completion of the dependencies, upstream dependencies. So the green color shows the fully completed code, tested, documented, which will never change in its API. The greenish color indicates 75% completion about, which means that the code is completed, but it may require certain updates of the API. It may require more documentation. It is not fully documented. It may require writing more test cases. So it's nearly there. Maybe even API wouldn't change, but there is still some work has to be done on these components. The orange color stands for alpha version. We call that half completed. You can say that this color 75% is sort of beta version, which may contain not full test covered, not fully documented, and may change in API, while orange 50% completion is an alpha version, which lacks certain forms of functionality. So not all functionality is there, or it even maybe not an alpha, but a proof of concept implementation not containing most of the functionality. The 25% marked with a red color, it means that this idea is a concept, and this concept may be defined as a protocol, but it doesn't have any code-based implementation yet. The violet color means that we know that we need this component, but we just even don't know how to do it. Specifically, we don't have even a specification yet. And the gray color means that we didn't know about that component at a certain point of time in the past. I will be showing some past history, so this color will be used to demonstrate that at that stage we didn't thought that such component is required, and it didn't exist even as an idea. And the roadmap will be composed of 4 main columns. These 4 main columns will stand for Lightning Network part of the story, which we called LNP, Lightning Network Protocol. Code that is relates to Bitcoin protocol itself, so Bitcoin blockchain, it's called BP, Bitcoin protocol. The RGB smart contracts, which are actually the core functionality of RGB itself. And the final 4th column is what we call Internet 2. Basically, it is networking layer that affects all of these components together. So that's why we separated it into a dedicated column. And we have a milestone, main milestone we will be talking today, which is an RGB public release. And I need to explain what in case of RGB, the release means and why it should be named Reckless. As I already said, the client-side validation means that once you release some technology using client-side validation and people start using it, you can't change the protocol. You can't do anything to it because any change is in fact a hard fork. And with the client-side validation, you have no way how you can coordinate the update of all people using RGB, of all software using RGB. Because in blockchain, you can have a signaling performed by miners, at least. It's not a perfect form of signaling, but you have that form of signaling. In Lightning Network, you have a peer-to-peer network which can propagate information and which can use special flags to indicate the version of software. So Lightning Network is easily upgraded, and there is no hard and soft forks there. You just add more and more functionality. With blockchain, you have hard and soft forks, which is more complicated case. And with the client-side validation, everything is a hard fork, and you can't coordinate and upgrade. That's why what we call RGB release is the moment when we say that protocol API and binary data structures would not change anymore. And that is release. But by release, we mean that it is not the release that is ready for storing a lot of value in it. It is reckless in a way that probably you shouldn't use it anywhere other than with the testnet. And as I said at the beginning of the presentation, with RGB, you don't have a concept of network. There is no network, there is no blockchain, there is no registry, there is no central server. So that's why we can't say that you have an RGB mainnet or RGB testnet. No, you just have an RGB contracts. And each contract is independent from the other RGB contract. And we think that each contract, at the genesis of the contract, the issuer or creator of the contract specifies which Bitcoin blockchain this contract should be using. Should it be mainnet or one of testnets, Regtest, Signet, or just normal testnet in Bitcoin? The decision to create a mainnet version of RGB smart contract is not taken by the developers, but it is taken by the issuers of the smart contract. So we have no control. That's why we can't do anything after doing the RGB release. We can't do a testnet release or mainnet release. We're just doing release and we can change it. And it will be up to the contract issuers to decide where they are happy with the security of this release to use it on the mainnet. And probably they will be deciding that independently from each other. So there will be no shift from testnet to the mainnet, at least the one that we can clearly see and say that, okay, now RGB is in mainnet mode. So that's a complexity that comes with the client-side validation paradigm. That's why we've put a lot of work into designing RGB in its final form, not leaving anything to, okay, we will do it later after the release, we will add functionality, we'll improve it. And that's why it has taken so long to get to where we are today. So what we can call a public release, which milestone can we call release? We do believe, after many internal conversations and experience with other developers who are trying to play with RGB at the early stage and users who try to play with RGB at early stage, the release of RGB should be marked not just with RGB node that can be used by a very well-experienced developers and has to be integrated with a lot of infrastructure like Lightning Node, Bitcoin Core, with a private keys using PSBD. So people are just not able to see how that will be useful, not developers. And that's why we decided that the proper RGB release is not an RGB node or something like that, which we already did some time ago, but it should be a wallet, a user-facing wallet with a nice UI that allows you to do everything, all the normal operations with RGB, at least with RGB assets, like issuing assets, sending them to a friend, and doing that also not only in main chain, but using the Lightning Network, creating invoices, looking for already issued assets. So the user experience, and that kind of wallet should be the point in time where we see the RGB being released. And when we also see that this wallet has the version of RGB which will not change anymore in its API and binary data encoding, we say that this is RGB release. Of course, there might be several wallets, of course, maybe more than one, but the release point is where we have at least one wallet with all that functionality available to the consumer. And I'm quite happy to say that we've been quite far with this part of the story. You have seen that it's nearly green, it's mostly done. And last spring, in March, we were demonstrating the first test version of the wallet that uses RGB. And this wallet was able to run on iPhones, iPads, and Mac OS operating system. Plus, we had a special server-side version of the wallet with a command line interface, so you can run it on Linux server. Or on Windows server or Windows desktop, but just with a command line interface. This wallet is called My Citadel. And why we can't say that we already have a full RGB release? Because of two reasons. The first reason is that some parts of RGB still changes. And this summer brought several updates, like we had to develop our own virtual machine. So the validation has changed, the binary data structure has changed. So we have to update the wallet to support this latest version of RGB. And the second reason, this wallet lacked Lightning Network functionality, because again, to bring together Bitcoin wallet with a Lightning Network wallet is a large work by itself, not saying about RGB integration. So we needed more time for doing that. And the next version, which will contain an updated version of RGB plus ability to use RGB over the Lightning Network, will be actually the release, will mark the release of RGB itself, as I just described. And additionally to this user-facing wallet, simultaneously with this release, we will release what we call a Citadel runtime. And the Citadel runtime is a binary library available to all wallet developers. And this binary library will be an engine of the wallet itself, which can be just plugged into existing wallets, or you can create a simple wrapping user interface around this binary library and develop your own wallet. And with this Citadel runtime, you get the whole pack of the functionality, starting from, of course, RGB itself, but also you got Lightning Wallet and Bitcoin Wallet supporting Taproot, Miniscript, complex multi-signatures, and many other things. And this Citadel runtime internally consists of many modules, which are completely hidden from the wallet developer. All that complexity is hidden. And the important part that this Citadel runtime can be fully embedded into mobile application or desktop application, or can be split across the mobile, client, and server-side components in many different ways, such that you may have a fully all-time operational Lightning node on your server, and you may still build a non-custodial solution with such setup. So it's a pretty much advanced thing, and you can use the Citadel runtime even without RGB, and in that case, you basically get the probably most functional wallet engine that is available today. I think that we will dedicate one of the talks, but down the road, more closer to the release, about the specific architecture of this Citadel runtime and how it can be used by wallet developers. So we have defined what we can name RGB release. Now let's see on which factors and which components across all these 4 columns this release is dependent and how we far from it. First of all, of course, let's start with RGB itself. And for doing RGB, we had to develop client-side validation foundation layer. And I'm happy to say that this August, sorry, not this August, it was this May, we had released the client-side set of client-side validation foundation libraries written in Rust. There is about 6 of these libraries that is released, different components like single-use seals, commit verify schemes, Bitcoin, deterministic Bitcoin commitments, and many different components. They are all released, fully documented, so we are happy with that part, and that part is finalized. The next thing that we should do is to finalize RGB core libraries. They're nearly complete. Some documentation has to be written, some more tests has to be created, some minor APIs has to be improved from the experience of testing RGB over the last half of year. But here we just have an update type of the work. And the difference between RGB and client-side validation is that client-side validation is more generic. it is not aware of any form of smart contracts. While RGB Core is actual implementation of RGB smart contract engine and the whole validation process. And the final component that is required for the RGB release is a specific schema for creating fungible tokens, which we call RGB20. And its API and functionality was also completed, but because it depends on the not finalized RGB, it is not marked as final as well. Sorry, I actually have a special slide explaining what are these client-side validation foundation libraries which are completed. And there are four main groups of these libraries. The first group is a foundation, which was released in May this year, and it includes main three libraries: single-use seal, commit verification library, and strict encoding, the encoding that is used across all the applications that we develop, that allows very precise encoding of the data that has to be kept on the client side. The second group of this client-side validation libraries is the libraries specific to Bitcoin protocol. So this is an implementation of client-side validation paradigms for Bitcoin protocol. And among them, we have deterministic Bitcoin commitments and Bitcoin-specific single-use seal implementation, because there is multiple ways how you can do single-use seal, and RGB uses just one of them, which we may call the UTXO-based pay-to-contract single-use seals. The third component, the third group of the libraries, and actually it's a single library, it's called LNPBP Universal Invoicing. And this is new invoice format, which already showcased how it works with my Citadel this spring. And this invoices allows you to combine not just Lightning Network and Bitcoin on-chain payment, same invoice, but combine them with RGB. And you also get a lot of functionality on top, like that you are able to specify multiple Lightning nodes to be paid to in the order that the user should try to pay to them, such that you may have a Lightning node on your mobile device, and Lightning node on your personal server, and Lightning node provided by your wallet developer company. And by giving an order, you will get the payment that if your mobile is offline, the payment will go to your personal server. And if your personal server has crashed, it will go to the wallet company. So you have these multiple failback scenarios. It also supports a lot of more functionality, and we had a big talk about universal invoices in spring. You may find it on the LNPBP YouTube channel, and I invite everybody interested to look for all this functionality that we put in there through listening to this talk. And the fourth group of the client validation libraries are libraries implementing some minor LNPBP standards, which were released, sorry, not today, the day that I was preparing the presentation, but it was like 2 weeks ago. And these libraries include extensions of back-32 encodings for special forms of client-side validated data, and some parameters allowing you to use different Bitcoin blockchains like testnets, mainnet, and potentially Liquid. Liquid is not yet working with RGB, but maybe somebody will work on that. There is nothing preventing technically from adding support of the Liquid to RGB itself. So we now know what has to be done and what's already done with the RGB smart contract vertical. Now let's move to the networking vertical, and there we had to create more advanced forms of networking protocols, which we called Internet 2. It is basically an extract of Lightning Network Bolt 8, which allows you all to tunnel the connection through HTTP and zero message queue. And we use this networking to build a special microservice architecture, which is used by Citadel runtime. And this architecture allows you to build a very scalable wallets that can span across mobile devices and server side, or even cloud, where you can scale the load on the cloud instances as needed, so up to the enterprise level. And fortunately, this was one of the first components we have completed our work on more than a year ago, and it's completely ready and tested and working. And we also know that this part is already used by other projects, unfortunately not Bitcoin, but there are Monero developers that just plugged it into their systems and started using it in completely RGB independent implementations, and they're quite happy with that. And finally, in this networking part of the column, I also put the Alluvium, which is virtual machine used by RGB. It is more generic than just client-side validation. It can be used in the future versions of web browsers or something like that. And we already developed the virtual machine itself, its Rust implementation, and we released it this July, early July. And we also developed not just the virtual machine, but a full-fledged assembly language, compiler, and linker for assembly code of Alluvium. And we also released it this August. So these components are fully ready. And I can show you how today the code written for Alluvium looks like. Yes, it's quite complex. It is assembly. It's not easy to write it down, but you see that at least you are able to program smart contracts at the low level using this Alluvium, and you are able to compile this program. So I'm quite happy that with the Internet 2 column and networking column, we are fully completed. Next thing is a Bitcoin protocol vertical. And with Bitcoin protocol vertical, it's a very interesting situation because on one hand, we can ship as it is today. So everything that is crucial to launch RGB today has been implemented in the Bitcoin protocol stack. However, there is such thing as taproot activation coming later this year in November, and it might be, while RGB itself completely supports taproot, in fact, in reality, we would like to make sure at least on the testnet that RGB indeed works good with the taproot and there is no problems, just not to patches of the taproot activation. However, we are blocked in this direction by the existing Rust Bitcoin libraries, because still the taproot support is not part of the Rust Bitcoin. We did quite a lot of pull requests starting from the beginning of the year, even before the voting for taproot support. Some of them are already merged, but unfortunately not all of them, and we do not know how long it will take to get them merged. Also, as a part of taproot activation, we need to update to PSBD format, partially signed Bitcoin format, used internally by RGB, including implementation of the new PSBD2 standard, which is also not done by anybody. So we have to make a decision when we will be completing with the other mostly Lightning-related components, to release RGB without these things and add them later, because they wouldn't change the protocol itself. It will be just a binary update, I mean the library update, but the functionality wouldn't change. Or we will have to fork Rust Bitcoin temporarily, merge everything that we have done for the taproot support, and then wait when the Rust Bitcoin will be updated by itself, and then remove this fork and fall back to using the main Rust Bitcoin library. So this decision will be taken later, either this month or at the beginning of October. Because it was kind of blocking us, but we decided that we can avoid this blocking by doing the thing that I just talked about. But additional to Taproot, this Bitcoin protocol column, what we had to do in it in order to get RGB working? Well, we didn't expect that, and it took several months of RGB from RGB development. But in fact, we had to update the existing components for Bitcoin wallets and Rust Bitcoin implementation in doing these things. First of all, we required a key tweaking, which is not part of normal wallet ecosystem. And this key tweaking required not only for RGB, but it is also a natural part of Taproot. So we had to design many structures and many wallet internal data representations and interfaces to Electrum server and others, such that we are able to track the addresses that contain a tweaked public keys. It wasn't easy part of the story, actually. And I think that it will be the absence of such support for the tweaked keys from all existing Bitcoin libraries, wallet libraries, will be the main factor which will slow down the Taproot adoption. So we think that by releasing this Descriptor wallet library, which we did specifically to this purpose, other wallets may use it or use just even a Citadel rhyme, and to get Taproot working much faster than trying to update the legacy libraries. Or the legacy libraries will be updated by their developers. The second thing is that we believe in strong separation between the private keys and public keys. And as you see on this chart, we have very distinct components. The one showed with the green is the component that maintains private keys. It can be a security module, hardware security device, hardware wallet itself. And the read-only part of the wallet, which tracks actually on-chain states and which contains the concept of which UTXOs are owned by the current user. And it uses a descriptor-based and miniscript-based definition of hierarchical deterministic wallets. But the problem that existing BAP standards about hierarchical deterministic wallets, they assume that you have access to the private key, because the private key is needed for doing hardened derivation of the wallet, hardened components of the part derivation. And basically, we ended up that finding that when you do such an architecture, you can't guarantee user that the wallet will be able to track on-chain transactions because private key may not be present. And the libraries that we were using basically crashing in these scenarios. So we had to re-implement the stack of the hierarchical derivation of wallets, and it also became the part of the descriptor library, which we released in February last year. Also, we had to move PSBT support, and we're still planning to do PSBT2 support, also in parts related to key tweaking. We had to we had to do many other minor stuff. Everything that became the part of the Descriptor library, and basically it is finalized as it is shown here. So we are quite happy with all these 3 columns, and I can say that there is, of course, as I said, we would like to have a Taproot support before the release, but it's not highly critical. And with everything like that, the only work that remains is just writing more tests, doing better documentation, and just going live, which is really, really good to have. However, there is a Lightning Network part. And since we said our goal is not just having on-chain part of the RGB within the Lightning, within the wallet, but also Lightning part, there is more things that has to be done on the Lightning Network part of the story. And this is a huge topic, which I would like to cover in depth in the several slides, but I need small pause to drink some water, and maybe we can use this pause to get questions if they had already appeared.
So guys, are there any questions? Okay, so far it doesn't seem so.
Okay.
When release? Yeah, okay.
Yeah, we are coming to that. So, about the Lightning Network, let's forget about RGB for a moment of time and look at the Lightning Network as it is today. and look at what Lightning Network should do in order to get better adoption and better functionality. I think that what we are talking about is shown on this slide. On one side, you have to add more core functionality to Lightning Network itself, like dually funded channels, which finally got their way into C Lightning. Unfortunately, they were not merged into bold specifications yet.
Sorry, Maxim, I
Yeah.
just see a black slide. I don't know if anybody else is also seeing black or
Yeah,
it's
can
just
you
my problem.
launch? Yeah, same here. Can
Yeah,
you launch
it's
the
a usual
presentation?
trouble with the presentation over Jitsi.
Okay, now I see the desktop.
Yeah.
Okay.
Dually funded channels. They already got their way into Lightning Network, not fully, but at least it's a big improvement because this slide was written like more than 2 years ago. I prepared this slide for the Lightning conference, which happened in September 2019, right, Giacomo, or something like that.
Yeah.
And
yeah.
Since that time, the only check mark that we got here, and we got it only this spring, is duly funded channels. Nothing else has happened for the whole 2 years for the whole Lightning Network. It's just amazing the absence of speed of the development of the protocol itself. But anyway, I will show
maybe. So
yeah.
the DLC experiments that has been done, they were not on the Lightning Network. Maybe yes, I don't remember. Well, anyway,
there is two
one or two.
experiments with the DLCs on the Lightning Network. Some of these things are blocked by the Schnorr signatures, like DLCs, Taproot itself, PTLCs. L2 also is dependent on the hard fork. But having said that, there is other problems preventing the upgrade of the Lightning Network, and I will be talking about them throughout several consequent slides. But also, I would like to say that while Taproot is already made it work into the activation itself and into Bitcoin Core, the work on Schnorr signature adoption and Taproot adoption to Lightning Network not even has started or even considered to be started. That's another part of the story. So we are in 2021, 2 years from when the slide was created, and we are not moving towards good progress here. Additionally to these things, we need to have such simple things like channel factories or multi-peer channels. We need to have a channel splits when you can split certain amount of funds out of the channel or channel factory. You may do many different protocols on top of the Lightning Network itself, including, of course, we are working on RGB, but there are other protocols like discrete log contracts and 3 protocols which we proposed before, several years before, but because we directly postponed them until the RGB is ready and completed and released, we has not started working on them. But these protocols can't become a part of the Lightning Network today without making channels, the structure of the channel, extensible. And today, the structure of the channel, the Lightning Network is set in stone and can't be extended. So this is all, in fact, blocked from further progress. So what we can do to get Lightning Network finally extendable and able to upgrade for new and new functionality with much higher speed. First and foremost, I believe that we need a proper standards rewritten. And by rewritten, I mean that some of these standards should be just better reorganized. The actual standard part of different bolts should be reorganized between themselves, because as of today, the story with the dual funded channels was that they had to modify each existing bolt to add just a single feature, because the way the bolts are structured, they are not structured to be upgradable by themselves. So just to rewrite them and split them into different layout, such that adding a feature will mean adding a single file, defining the protocol for that feature, and not modifying all existing standards. And to highlight that, again, I'm taking the slide from the 2 years ago, the Lightning conference, which we did together with Christian Decker. He originally proposed this architecture of the Lightning Network, which is a bit outdated. Today I will be presenting more recent understanding of how Lightning Network may be structured. But anyway, it's architecture of the Lightning Network, as it's seen by Christian Decker. And here, how the both standards defines parts of this architecture. And as you can see, this is a complete mess. So of course, if you need to add feature or a layer, you end up with a multiple conflicts between different standards. It's really hard to write a proper definition of new functionality, and even much harder to review it. And that's why reviewing takes like months, if not sometimes years. So we already did part of that work. At least we split what can be split from today goals and put them as a separate LNP-BP standards, defining networking layer in particular. However, the writing standards and creating new standards for new protocols is not enough. What we have to do is also, we have to reduce the complexity of adding new functionality to the Lightning Network. Because today, this architecture, which I showed, exists only inside the head of Christian Decker and other people like René Picard, me, and many others, but not in code and not in standards. So there is no layerization of Lightning Network protocol itself. And of course, you can see that there is no layerization by the fact of how bolts are organized. And you simply can't add new functionality in some predictable and reviewable way. And additionally to linearize and layerizing standards themselves, we need to layerize the protocol. And in seeing the protocol, we need to create a clear extensions point, because extensions point that presents that are part of the Lightning Network today, such that TLV, type length value extensions, such that feature flags and message types are not enough. They all exist on the same layer of the protocol, mixing different parts of the protocol together. We have to separate the layers and add extensibility specific to each layer. And again, of course, I will be talking about that more on the consequent slides. We also just not have to define all of that. We have to do a reference implementation of this stack, and we call this reference implementation LNP Core library. We have started work on LNP Core library more than a year ago, actually exactly a year ago, and it was finalized in its very initial form with this layerization of the architecture near the last new year. And today, after working on all other aspects which were required for RGB, we're coming back to completing the LNP Core library with all that stack and extensibility. And finally, the library itself is not enough. Of course, it can be used by other projects, but we have to develop a full Lightning node, which we called Lightning node on top of this library, which will be able to, so that anybody can launch it, download it, compile, and run Lightning channels, talking to existing Lightning nodes and Lightning LNP nodes with the support of all this new functionality, and talking to existing Lightning nodes in the legacy mode. And additionally, we should use this LNP node as a part of the SDK that we do for wallet developers, which is Citadel runtime, and as a part of our wallet to showcase and demonstrate that this node is indeed working and allows you to perform both legacy Lightning operations and new operations, such as operations related to RGB. So let's go briefly through the steps of this process. As I said, the step one, we need to separate. No, I didn't say that. So I said what has to be done, and now I would like to put all this, what has to be done, into three consequent steps. And the first step is to separate networking protocol from the payment protocol. As René Picard said in he's a co-author of Mastering Lightning Network, And he is so frustrated by the way Lightning Network protocols are organized today because they're spending years trying to describe that in a book in some consistent fashion, and still they are not happy with the result that they got so far. And he said that this was clearly one of the largest mistakes, that the Lightning Network in its design didn't separate the networking part from the payment part, where the payment is clear an application thing, specific thing, and you may have many more applications within the concept of the state channels other than just a simple payments. And networking part, which is a peer-to-peer protocol. It's like if Bitcoin never separated Bitcoin wire protocol from the structure of chain, which will be really ridiculous. And we need to do that separation now. And here I summarized. I wouldn't have time to go into the details here. I spent quite a lot of time explaining this slide on the conference, Crypto Castle conference, which took place the last week. Unfortunately, the video is not yet published, but it will be published soon. So probably I will ask everybody to look into that. But basically, within the scope of networking, we may say, we may speak about session level protocols such as noise X key, specific noise X key implementation used by Lightning Network today. It is defined in Bolt 8, the most part of Bolt 8, of course, not full of it. So we have already extracted it from Bolt 8 and created a LNPBP 15 standard, which is just exact copy of the session level part of the Bolt 8, just to separate it from the rest of the standard. There is also a P2P messaging protocol as it exists today, and as it should be extended to allow other functionality which we were mentioning before. And there is also another networking protocol, which is Sphinx Onion messaging. It's frequently called Sphinx Onion routing, but this name is a little bit misleading because in Lightning Network, there is a route funding protocol, which is not a Sphinx Onion routing. Sphinx Onion routing is used just to route message when you know the route already. So you compose the Sphinx packet as a layers based on the route information that you already have. And this allows you to deliver in an anonymous way the message to the destination. However, to construct such a Sphinx Onion package, you have to use a special routing protocol, which is not part of the networking stack. So Sphinx, that's why I renamed the Sphinx protocol to Sphinx Onion messaging, not routing, because it's not about routing. And the second, on the right side, we have the protocol specific to Lightning payments. And today, on each of these bullet points, there is only one protocol that is used by Lightning Network today. And of course, it is embedded into the bolts, mixed with all other protocols altogether. But the case that to do all the stuff that I was talking at the beginning of Lightning Network part of the presentation, it requires to add more protocol on each of these layers, more protocols. So we may have a better protocols for discovery of the network topology. Today, we use gossiping and minimum base fee finding algorithm. There is a great proposal by René Picard into how you can do a multi-path finding with a different routing algorithm, not for gossiping. You reuse the same gossiping, but sorry, even without gossiping. There is another protocol that allows you to do a better routing proposal and routing. And we have to enable experimentation with the new protocols to unlock the problems that we have with the routing in the Lightning Network today. We should, the next layer is how we encode specific data inside the Lightning Network messages. And there might be better ways or other ways of doing that. So this layer should be also extendable. The structure of Bitcoin transactions has to be extendable because you need to add more outputs of different types to support discrete log contracts, to support storm type of contracts, to get a channel factories finally working, and so on and so forth. What I call staking protocols is basically, you may think about Lightning nodes as nodes that stake their Bitcoins, stake their liquidity inside the channel, risking this liquidity to prove that they are not cheating, because if they will cheat, this money will be, the stake will be taken from them by the other party, and they will lose this stake. So you might think about Lightning Network as already a staking layer on top of Bitcoin itself, initial form of BFI application, and there is more than today present day staking with this penalty algorithm. There is other way of organization of Lightning Network responsibility, which is L2. And yes, it will require hard soft fork at the Bitcoin layer, but even if it will happen, the existing architecture of the stars and nodes wouldn't be able to adapt to it because it is not extendable. So we need extendability at the staking protocol level. And finally, the protocols enabling cryptographic atomicity of the channel updates, basically multi-hop payments. Today we have HTLC protocol for that, but we have already a better protocol based on Schnorr signatures, which is PTLC. And again, this layer is not extendable as it's today, and we have to make it extendable. And on this slide, I took the left-hand parts, actually both of these parts, and put them into the stack diagram, such that we are clearly separating the networking layers, transport layer, which is TCP/IP, from session encryption at the level of internet protocols. And you know that Lightning Network works well with a Tor, with VPN, IPsec, and actually you don't need TLS SSL encryption to work with the Lightning Network at all, because it has its own session encryption layer, B, which is Bolt 8, actually part of the Bolt 8, LNPBP 15. On top of this session level protocols, we have API messaging, peer-to-peer API messaging layer, which composed of 3 standards today, Bolt 4, Bolt 1, and Bolt 9, at least parts of the standards. On top of that, we have algorithm for route exploration. Today it is gossip routing, route network topology exploration. In the future, it might be different algorithm like ANT routing. On top of that, we have a staking synchronization protocols like HTLC and PTLC. And only on top of that, we have application layer, which are payments, and in future DLCs, channel factories, RGB, and probably many, many more standards. And the case is that each of these layers shouldn't know nothing about layers on top of them. Each specification defining this layer should provide A, the way to extend this specific layer, and B, should not depend or reference specifications of the layers above. And that will allow adding applications to the Lightning Network without modification of existing Lightning standards, which is the most important for network extensibility, evolution, and gaining better functionality. So we have already separated networking from payment protocols. The next step, we should generalize channels, such that today's the present structure of the transactions which are part of the Lightning channel is fixed in stone. You can't change it, otherwise signatures wouldn't apply. It makes even the Lightning Network incompatible with the key tweaking of RGB auto uproot, because the key tweaking definitely changes the hash used for signing transaction. We need to solve this problem, but even more, while solving this problem, why would we not generalize the structure of the channel transaction such that nodes will be able to negotiate what specific types of outputs they will put into this channel? Like allow them arbitrarily combine HTLCs with BTLCs, allow them arbitrarily combine channel factories with the channels, add DLC types of outputs, and so on and so forth. Do splits by introducing additional transactions inside the channel. So yeah, just basically, this slide shows what I said in the previous one. And the final step is we need to unlock the layers 3, this layer on top application layer, for building more applications and building even more things on top, like decentralized exchanges and other forms of BFI or data storage network on top of Lightning Network, which can be greatly implemented but not without the Lightning Network refactoring as I just described. And this all comes to the application layer that allows extension of the networking part, not touching the state channels, because Lightning Network is a great P2P network, and you don't need to invent a new network to exchange messages for things like, probably the Sphinx Messenger to send the private messages. You don't need to extend the payment channel protocol. You just use P2P network. The same applies for doing things like DAX or data storage, or running data queries about the data stored by the Lightning Network, and so on and so forth. And there are other protocols which require the change of the transaction structure. This also should be enabled. So now we see what has to be changed in the Lightning Network to get Waterby working, Taproot working, and get extensibility to the Lightning Network. And what would be the way how we see this happening? Well, there is several ways. The first way is just to try to change all the existing bolts altogether. This way doesn't work because even much smaller changes like dually funded changes are not got merged. So we can't go proceed this route, otherwise it will take forever. The other approach is to develop a new protocol aside from the existing set of bolt standards. This protocol should be a strict extension to the bolt standard, so it shouldn't change anything that exists in the bolt today. It should just refactor the way they are structured into a layered form and add all that functionality I was talking about on top of that. And not just add this functionality, because it will take a lot of time to define all these extensions. But by creating a proper structure with the standards, allow this extensibility in the future with new standards, which may be created by any third party interested in that. So just define the extension point, define the layers, and define the extension points on all of these layers, and start with the stuff that we require just to start using RGB, and let others work on other specs they are interested in. And because nevertheless, this approach unlocks the way forward, it creates additional risks, because the Lightning Network more or less stabilized, and there is a lot of liquidity there already, and we don't want to risk that liquidity by not distinguishing the new stuff from the already proven, from the stuff that already proven to be working. That's why we think that this extension of the Lightning Network, strict extension, will be called differently, Bifrost, and this Bifrost will be a new protocol that run in parallel with the Lightning Network, such that when the one node, let's say that you have a node, LNP node, supporting the Bifrost, what you will do is first you will establish a normal Lightning Network connection to the remote peer, and then you will send a special message asking the remote peer, would he like to upgrade to a newer Bifrost protocol? And if the peer do not reply to the message, such that it hasn't understood it, or replies with no, you basically continue to using a normal Lightning network in a legacy way. If the peer upgrades without the additional functionality like RGB, you wouldn't be able to use RGB in this channel. But if the peer supports the upgrade, you will establish a second connection of a different port address, and this connection will run this upgraded protocol, which we call Bifrost, with all extensions that may come on top. And this allows us to maintain the networking power and networking effect of existing Lightning Network, separate the risks of using new networking protocols, and allow to fail back to the Lightning Network any moment in time if something goes wrong with a more reckless Bifrost network. And that's why we call that reckless square, because it's not just reckless like Lightning Network, but even more reckless. That's actually what I just described already, summarized on this slide. And with the introduction of Bifrost, we are getting this form of diagram where the green components are the components which are Bifrost themselves or and extensions that become possible because of the Bifrost. So these things are realistic to be implemented only with the Bifrost support. And this includes ANT routing and PDLCs as well, additionally to all RGB channel factories and DLCs. This is a technical summary. Probably I wouldn't spend much time on that. It's just you may look slides after the presentation. I mostly already said all of that. It's just more specific details. And the aim that with a Bifrost, anyone would be able to propose an extension or a new application for Lightning Network at any of the levels that I just mentioned. Routing, payments, custom structure of channels, or even pure data propagation or storage applications which are not affecting payment channels at all. And they will be able to do that without the need to standardize it or before experimenting with that. And because doing such experiments is not only about writing standard, but also about doing an implementation and literally using it, we see LNP node that we developed for at least some period of time. It will be the only node supporting Bifrost, and you will be able to develop extensions to this node to get ability to experiment with new protocols. And we just hope that other node developers, Lightning Labs, Blockstream, Async, will work on Bifrost support in the future, such that they will unlock the extensibility I was talking about as well. And if you will take this route, extending the Lightning Network and writing your own applications for the Lightning Network, what you will have to do is to fork LNP node and write the Rust extension and compile it together with LNP node. That is as of today. However, we planned for the next year, after the release of RGB this year, to add support for better hot pluggable extensions to LNP node. And these hot pluggable extensions will run on Alluvium, actually. And basically, you will not need to compile the LNP node or download it or fork it. You just plug in the library with Alluvium, and you will get new types of channels and new applications for the Lightning Network by that way. So that's why I said in the very beginning that Alluvium is not just for RGB, it has more generic parts. Important part, because it's really, really easy to mix with the terminology. We have a lot of layering here. We had a lot of protocols on each layer and extensions to protocols. So I would like to set the record straight to the way how we use the terminology. I have to confess that previously we were not strict. We hadn't even the idea how we will define certain terms. We just started using them. But today I would like to put a very strict definitions to the following terms. First of all, LNP, which we were talking about, Lightning Network Protocol. It is everything of Lightning Network as of today, the legacy Lightning, and as of tomorrow, which includes Bifrost and all the applications. So it's not generic thing. It's extension of Lightning protocol. It's everything that works with the Lightning. It is LNP. And you may see that on this diagram that it is everything that is above the blue layer, above the session layer. Yellow, black, or green. This is LNP. And that's why the slide called networking protocols in LNP. The second term is Bifrost, which is a part of LNPBP. It's a specific protocol for the new Lightning P2P messaging. It is a layer of extensibility of LNP, allowing and unlocking custom applications. And this protocol will be used by other applications like decentralized exchange or RGB or data storage layer. But these specific applications like RGB DEX, they are not part of the Bifrost. They are using Bifrost. So they are built on top of Bifrost. And the third name that we were using completely in different context before, but I would like to propose to use it in this very specific context, a kaleidoscope, which will be a layer of decentralized exchange combining developed on top of both Bitcoin, of both Bifrost and RGB. So Kaleidoscope is decentralized exchange working on top of Bifrost and of course requiring RGB. Jack, do you have any objections to this proposal because you are the author of all three terms, original author?
No, absolutely. As long as the terms I'm in love with are used, I will love any kind of use. This makes sense.
Okay, thank you. So we are getting this stack once again. We see how these protocols stick together. And there's a few words about Bifrost. Bifrost is the protocol about how the nodes communicate and exchange comments and data. Bifrost doesn't know anything how the command should work. It's just the way how you pack the data and comments together and send them over the wire, such that the other node will understand them.
Oh,
And
sorry, Maxim. Sorry to interrupt you. I just had an idea right now about the naming. There may be some relics, some remains of past uses of some names that maybe it could be a good idea to try to search for and collect and insulate. Maybe we could just eventually, not it's not a priority, but we will have like an historical page explaining some legacy uses of the name. Because, for example, Kaleidoscope may appear as the Alecos MVP wallet, RGB wallet, and Spectre was the previous name of what is now Kaleidoscope that then passed it on to John's wallet. So there may be some kind of ambiguity. So I'm super fine with these final ultimate terminology, but probably we may be aware that we may have disseminated around GitHub some legacy terminology to correct.
Yeah, I do agree. And it should be separate page because most of people, not a lot of people know about RGB today, so we shouldn't confuse them with this ambiguity, but clearly we should have a page where people who knew about RGB before and heard these terms will click a link or asterisk or some reference and see that how to disambiguate them.
Yep.
So Bifrost is the layer how you communicate with a new protocol, how the Lightning nodes can communicate and send messages each other with this new protocol in parallel with the legacy Lightning P2P messaging. And this Bifrost allows, so this is not part of Bifrost. These are things that is done on top of Bifrost. And Bifrost allows things like publishing information about RGB assets. So basically, you are able to connect other Lightning node and ask other Lightning node through Bifrost protocol, which RGB assets do you know? And that's how you can get information about existing Lightning assets in a decentralized way, or information about that the issuer has created a new issuance and inflated supply of the asset. This will also be done in the same way. So it's not just that you will need to scan QR codes and go to the issuer website. You will have also decentralized alternatives working on top of Lightning Network. And the same Bifrost will be used for sending RGB consignments, even for on-chain payments, not just for Lightning Network payments. And in fact, for Lightning Network payments, you don't need to send an RGB consignment, the way it works. But for on-chain, you have to send this client-side validated data, and we call this bulk of client-side validated data RGB consignment. And instead of creating new network or creating new protocols for that, or using some weird things like using back encoding and sending it over Telegram. It could be megabytes of information, not usable, or binary file. We will reuse the Lightning Network through this Bifrost extension layer. It is also that you can provide prepaid storage features for maintaining data backups or maintaining consignments while your wallet is offline, RGB consignments while your wallet is offline, or storing the blobs of NFT data, which are also used by RGB. So you can ask other node to do that for you, pay some amount with Bitcoins through the Lightning payment, and later query this node for that information. And it's not hard to do, and it will be a natural part of this extension of Lightning Network with a Bifrost. And with that, you instantly get solution for baking RGB client-side validation data and also for baking the state of your channels, again, in the centralized way, because you may ask multiple nodes to help the data. And also you can encrypt this data with a certain specific derivation path from your hierarchical deterministic wallet, such that it is only the seed that you have to know to be able to recover the state of the Lightning channels and RGB client-side validation data. The next thing that will be unlocked is with that, it's quite easy to move to the generic query network. You may think that there is nothing preventing you from having a BitTorrent over the Lightning Network, where you will incentivize the storage of information with Lightning payments. And you may also query this network about different type of data, like, do you have this file? Or where I can find the pieces of this file, like in BitTorrent? Or do you know this asset? And what information of the asset you know? And you can collect this information from the network. So basically, you convert Lightning Network into the vision that we had about LNP originally, that it is a true internet two-layer of the LNPBP stack, solving the same application needs like internet and web 3 or web 2 today, but in a decentralized fashion. And it's not the way the web 3 work, which is decentralized or scalable. This should be much more scalable what it is done on top, not of blockchains, some weird blockchains, but on top of the Lightning Network. Also, Bifrost, additionally to this application, it allows more complex applications like better RGB-enabled watchtowers, more types of channel operations like channel splits, channel refunding, DAO funding, more types of channels like channel factories or storm-type channels, and adding more types of commitment transaction outputs to the channel itself, like DLCs required for DLCs and Lightspeed. So that was Bifrost. Now a few words about decentralized exchange, Kaleidoscope. We've had quite a hot discussion over the Telegram chat. There is a lot of questions. I wouldn't be able to explain all of them in just 2 slides that I have. 3 slides, okay? But I will able to try to explain how it will be working. The fact is, Lightning Network today already has all the information about liquidity. You don't need to change anything here even, because when you announce a channel, you announce liquidity. This is the part of the gossip protocol. This is required for nodes to construct the payment paths. And this information available to the node today and used by the node today. And you know that Lightning Network is a multi-asset protocol by design. And it can operate not only Bitcoin today, as it is today, it just operates only Bitcoin, but nothing prevents you to add Litecoin or liquid assets to the Lightning Network, except that network can't work with a liquid blockchain, but that's a different topic. And of course, when you add RGB assets, you don't break anything, because you will use the same gossip protocol to announce information about your liquidity and RGB assets. This is why, once you have RGB part of the Lightning Network, the network topology will be natively extended without any change, with the information about not just Bitcoin, but all other asset liquidity. So this part is already there. We don't need to change anything to get DEX working, to get know about liquidity state of the network or network topology. However, we don't know the exchange rate, so we don't know which nodes to add to the path, and we can't actually construct the fees and the actual amounts required for an exchange. And while the initial idea were to add this information to the gossip protocol, first it will break the Lightning Network standard compatibility. And the second, if you will do that over Bifrost, not all nodes will support Bifrost. So this information may be lost through the gossiping. And it is not scalable, because it's really bad to bloat gossip protocol. And it will be really nice to get rid of it in the future, for instance, introducing different forms of routing like unt-routing. So we can't guarantee that it will be always there. So we found a different way. You don't need to publish that information to the whole network. Once you see that the node has liquidity in two different assets, which you need to exchange into one another, you just establish a direct Bifrost connection to that node, because all the nodes that support RGB assets, they have a Bifrost support. And you just ask that node in a moment, what is an exchange rate? And you get the answer, and you construct your payment using that information. This is very scalable, private, and very simple to do. The final problem that you have to solve is a American call option problem, which is basically a problem related to the fact that the node can hold the payment or exchange the fulfillment of the payment by not publishing HTLC to other node, such that it can gain the best exchange rate by itself. And this problem is solvable. We haven't finalized the solution yet, but the intuition into the solution we are researching into is that we can use the same HTLC or PTLC coupling. So for exchange functionality, you will have just not a single HTLC, but two HTLCs. And the payment, if the payment is not exchange, is not fulfilled into the certain scope of time, the exchange node will be actually penalized for not fulfilling that. That will remove the incentive to run the reverse American call option. However, even without this part being finalized, the DEX will be quite well functioning, at least for at least a year before somebody will, with a lot of liquidity, will try to attack it. So we will have time, and because Lightning Network, and very fortunately, Bifrost part, even in RGB specific part, is easily upgradable. That's the whole area of the protocol design. We are not in the client-side validation world here. We are in Lightning Network here. So we can add that solution later, and protocols like Kaleidoscope will be released in an upgradable fashion. Interesting that this design do not require neither order book. There is no order book in this network to maintain to, which reduces a lot of problems, removes a lot of problems, and there is no requirement to have a liquidity pools in such a design. You may have them, and I will show you how you can construct a liquidity pool with a Lightning Network without even RGB. But you just don't need that without RGB because you have just a single asset, nothing to exchange into. But you don't need this liquidity pools to get this DEX working. It's a new type of DEX. So graphical explanation of how this works. Let's assume we have the following Lightning Network topology. And the Alice at the bottom would like to pay to the Elon, shown in green, his name shown in green, on the right side. And this is the whole topology of the whole network. So the first thing that Alice do, she finds the path from her to Alan. And there is only a single way to do that. It's through Bob, Carol, Dan to Alan. But there are two assets in this network. The red lines shows USD, some form of stable coin on top of USD with RGB. Let's call it USDX, liquidity in that stable coin. And the orange lines are BTC liquidity. And there is no path from Alice to Alan without with just USD liquidity. You can't make USD payment because there is no liquidity route with the liquidity in USDX. And this problem may be solved by utilizing Kaleidoscope. So what you will do is first you define this route, which you need to perform a payment, and you have two nodes, Bob and Dan, which can do an exchange. Bob will exchange from USDX into BTC, and Dan will exchange from BTC into USDX. So Alice first connects to Bob through Bifrost and asks, Bob, what is your exchange rate? Okay, she got it. Then she connects to Dan and asks, what is your exchange rate? Okay, she has all the information about network topology, liquidity, and exchange rates. She constructs the payment onion packet, sends it over, And the payment is fulfilled with nodes performing not just multi-hop payment, but also exchange operation, earning their commission. That's so simple. That's a DEX. No blockchain, no Turing completeness, nothing is required here, just a Lightning network. And you have a full scalability in number of transactions through output. So that's all about Kaleidoscope as of today. Hopefully this answers the questions that we had. The second thing is liquidity pool. Can you do liquidity pools with Lightning Network and RGB? Yes, you can. But to do liquidity pools, you need more complex setup. Specifically, you need both support of RGB channels, because it makes no sense of having liquidity pool, as I just said, if you have just a single asset, and of Schnorr signatures, because you need aggregated signatures, and of channel factories. If you got this support into the Lightning Network, you can construct a liquidity pool. Here is the setup, how you can do that. So there is, on the left side, in blue, you have 3 participants of the liquidity pool, which put their liquidity together, and they construct N of M multi-sig channel factory. Perfectly, it should be 3 of 3, such that nobody trusts no one. But because all of them has to be online, in a large setups, when you can have a public liquidity pool with hundreds of participants, probably it wouldn't be reasonable, and it will be quite vulnerable to somebody going offline. The liquidity pool will be stopping from operating. So in this case, you can have N of M, like 50 nodes of 100, or 51 nodes of 100, still rely on the same assumptions of the honesty of the majority, which is a normal assumption to decentralized Bitcoin blockchain world. And you will have flexibility of nodes going offline. So this setup will be really hard to attack. So that's why we can propose the construction of liquidity pool, still trustless, with an N of M multi-signature channel factories. And this channel factory creates 2 channels to 2 different participants. So it's internal channel factory. One with incoming Bitcoin liquidity, and the other one with outgoing USDX liquidity. And you get Bitcoins on one end. You use your liquidity from the pool to pay USDX on the other end, and you can even use a curve function inside to generate your exchange rate and inform other nodes about it through the Bifrost protocol, as we just described in the DEX part. And this is the same setup as you have with a Uniswap or something like that, but no on-chain transaction, no Turing completeness, no vulnerability to the code written by the smart contract developers, exceptional privacy. So that's how it can be done. Again, coming back to the promise in the first slide that it is possible to do whatever you would like to do with Ethereum, but in more confidential and scalable way on top of the LNPBP stack. Finally, roadmap. Sorry, I know that it has taken quite a long, but we are nearly there. How we will launch all these extensions and finalize the LNP stack. The stage 1, which should be completed together with the completion of RGB, and it is required for RGB to get properly working with the Lightning Network, will include Bifrost as a core protocol that allows this extensibility, not all these extensions on top, but just a core messaging layer, publishing information about RGB assets on top of Bifrost, and sending RGB consignments. That's all. So we hope to complete that till the end or middle or start of November 2021, depending on our luck. The stage 2, after RGB release, which will be completed the first half of the second year, will include upgrade with the Schnorr, Taproot, and PTLC-based channels to the Lightning Network, again by using the Bifrost functionality, and more RGB specific applications like sending, storing NFTs, non-fungible tokens, not in blockchain, again, like in Ethereum, which doesn't work, or not on a file or website, like in many other NFT systems, but as a part of the centralized storage network with the incentivization in Bitcoin payments. And also storing backups, encrypted backups, and running watchtowers. So I'm expecting the first half of the next year. The stage 3 will be implementation of these decks, as we described Kaleidoscope previously, and potentially liquidity pools. Not 100% sure that it wouldn't take more time. And stage 4 after that, we will use on long-term projects like Storm and Prometheus, which are even more complex setup of data storage, where the storage is not prepaid, but you have a full guarantee that you wouldn't pay unless you got the data, and the data provider will be always paid if he stored the data, even if you disappear. This is Storm what we're about, and also Prometheus, which will allow the large-scale, high-load computing on top of the Lightning Network. But it will 2033 and maybe later. Coming back to our scheme, original scheme, we see that there are certain components which we need to complete to get the release. Specifically, we need to develop the core of Bifrost protocol, and we need to finalize RGB consignment sending of RGB consignments over the Lightning Network, and update like LNP nodes to support both of them. After that, we have RGB release. When we have the release, there will be much more to be done for the LNP part, which we just described. It's all listed here in the left row. And there, of course, will be more that can be done for RGB smart contracts. These things will not require the change of RGB protocol. This will be just specific smart contracts developed by LNPBP Standards Association in form of schema and Alluvium scripts, which will allow us to handle stablecoin gates from existing stablecoins, RGB non-fungible tokens, but maybe in a year from now, slightly less algorithmical stablecoins. We already have design for that. And even more complex smart contracts like running identity in quite anonymous, not in oxymoron. It's really that you can do an identity in a confidential fashion, and decentralized naming systems. We had a presentation about that this spring, how they can be designed with RGB. Additionally to that, we will have to be working on other projects like improving the indexing of Bitcoin blockchain to get RGB working faster and more efficiently, or in the future potentially developing sidechains specific for client-side validation to get some applications of client-side validation running faster. Of course, compromising on trustlessness. If somebody will need higher speed and can't compromise, that can be also done. And maybe the most important part from the developer's perspective, we will work on the specific language dedicated for writing RGB smart contracts and creating tool chains simplifying developers' life and allowing developing complex arbitrary RGB smart contracts to any third-party developers. And this language called Contractum, we did a sneak peek of it in one of presentations this summer. It is Haskell, non-JavaScript, but Haskell-inspired language. It's not a subset of Haskell itself. It's like follows certain language design from Haskell. It avoids visual clutter as much as possible. It focuses on the validation procedure, so completely different approach to Solidity, where you focus on state and business logic and not on the validation of the new state. It avoids foot guns as much as possible, and it is designed for composability and with category theory on mind, and it is made for formal verification. This is how the implementation of RGB20 fungible token in this language may look like. Not a lot of code, as you see. There are fields, there are certain rights like homomorphic rights and rights for doing renomination. There are genesis, which contain certain fields and definition of certain rights, optional and non-optional or multiple, like allocation. There is a verification procedure that verifies the consistency of genesis data, and state transitions. Additional to state transitions, again, taking input of previous state and generating a new state, verifying the correctness of the iteration. There is a methods that allows to read the state of the smart contract, like the last method total issued. Very, very simple. Focus on verification, because all the code except the declaration of the fields and state transition is actually verification statements, starting with the assert word. That's the whole roadmap for RGB. And how far we are from the release? Well, in the 1st of January 2020, half of year after I started working on RGB, we were this far. Like, we had nothing. The most of the concepts we were talking today, we hadn't even an idea of that we will need them or that we will have to develop them, like Descriptor wallet library. We believe that existing Bitcoin wallet libraries will be sufficient. No, they don't. They won't. We just had initial work on the client-side validation and very initial drafts on RGB core components. We thought about possibility of DEX over the Lightning, and we already knew about the Storm protocol, but it was so far from getting there with the RGB that we had that it's hard to imagine how much we had actually to do in order to get here. In 1 year from that time, we've got much more things. We completed the networking part of the protocols. We progressed in client-side validation and RGB implementation. We started working on the Lightning networking part, and we already had the current LNP node. We knew that we have to develop other LNP messaging protocol and use Lightning network to propagate RGB data. And we started designing some other components, which will be finalized after the release, but the work on them have started before. So over the first half of the 2021 year, we had very dramatic progress with all of that. We have developed Descriptor wallet library with the support for key tweaking and complete separation of private and public keys for hierarchical deterministic wallets. We did a runtime for RGB-enabled wallets, Citadel runtime, and we did a first RGB proof of concept wallet, my Citadel, running mobile, desktop, and server. We made a lot of work on Taproot and Schnorr support, in general, Rust Bitcoin and SecP library, not even as a part of RGB. We released the client-side validation foundation libraries, and we have developed a virtual machine for validation of smart contracts, created its instruction set, assembly, and linker, which are completely ready now, right now. So this is where we are today, and we expect by the end of the year, we will get here with a release and even slightly more. Let's see where we can get to the release point. Today, RGB and underlying foundation code base consists of about 1 million lines of Rust code created over the last 2 years, practically exactly last 2 years. We had a multiple of rewrites, of course, over the course of time. For RGB going live, I expect that we need another 150K lines of code to write. And I think that this is doable, taking into account the previous speed of the code writing within the 2 or 3 months. Main tasks and challenges that remains today to complete RGB is the finalization of Taproot and Schnorr. Basically, it is there. We just need more reviewers and get it merged into Rust Bitcoin. If we wouldn't get that, okay, we can move forward without that, but it will be nice to have. We have to do a full PSBT implementation, PSBT2 implementation, which again, nice to be used in RGB, but we can fail back to PSBT1 standard and it wouldn't create a problem. So we're looking for co-authors which we may help us to do PSBT2 implementation. We need to work on the Lightning Network design to adopt the Taproot. Again, nice to have, not necessary. What is really necessary is the completion of LNP nodes. And this is where, like, it's 90% of stuff that is required to get RGB released in this form, which we defined here. And we are looking for contributors to LNP node. The good news that is Peter Todd expressed interest in being involved into RGB completion and audit of existing protocols and code base on a half-time basis during the whole next year, at least, which we are happy that we have such strong, experienced developer and auditor. But still, we are looking for strong knowledge for people that can come to the team and will have a strong knowledge of Rust, excellent knowledge of bit protocols, including Taproot and PSBD, good understanding of LN internals. It's optional because we can do other stuff which is not Lightning Network related, but the most important part now is Lightning Network. So it would be nice to have somebody with a good understanding of our Lightning Network internals and at least some basic understanding of client-side validation and RGB concepts, which if it is absent, it's not a hard problem to acquire it from watching a couple of videos of the YouTube that we made before. These are all organizations with a multiple repositories composing different parts of RGB protocols, which are on the GitHub. We have 3 main repositories covering LNPBP stack, standards, client-side validation, Bitcoin protocol, and Lightning Network protocol. We have a dedicated organization for RGB smart contracts specific code and reference implementation, and including the languages, contractum language, RGB.org. We have a dedicated organization for networking protocols and Alluvium, Internet2.org. And also, I already several times mentioned these future protocols, which will be developed after RGB and Prometheus. We are not working on them yet, but you may look into these 2 organizations. They have a specification of the protocol, and you may find this interesting. And of course, we'll be happy to hear your feedbacks or some vulnerability reporting. This is all run by LNPBP Standards Association. I already mentioned it. It is a Swiss association, completely legal, but not registered, which is correct under the Article 6 of Swiss Civil Codex. We have founded it with Giacomo Zucco. It oversees the layer 2 and layer 3 related standards and software development. Today we focus on RGB, but we will work on more protocols as I just described in the future. And we got already a lot of contributions, ideas from most prominent cryptographers like Peter Toth, Adam Beck, Andrew Palstra, and Lightning Network developers, including Christian Decker and Brené Picard. This is our website. Not a lot of information there, but just for everybody to know. And that is all for my part and for today. Ready for your questions.
Wonderful. Thank you, Maxim. There is a couple of questions already. Probably I'll go backwards. If you have any, there are like only a couple of them. So everyone else is free to think about the other ones. So regarding the DEX, the question is, will the exchange rate be always RGB token to BTC, or there will be RGB token 1 and RGB versus RGB token 2?
Nothing prevents you from changing one token into another, avoiding BTC part.
Okay, so it's not.
The answer is yes.
Okay. No, there's no. The answer is yes. You can. One person can build RGB token 1 versus RGB token 2 platform. That's
correct.
The answer. Yes.
Not platform. Just run a node that will do that type of exchange.
Yeah. Okay.
It's just a question of configuring your LNP node or other Bfrost enabled node once there will once such nodes will exist.
Next question from SuperTestNet. I have the impression that my Citadel wallet is iOS, macOS only. Is that true? For now, Maxim, probably you can answer that.
Yeah. Well, the user interface, the fluffy user interface today exists on the iOS and macOS, but Citadel runtime is absolutely cross-platform, working on everything that you can imagine, everything that actually compiles Rust, including some routers maybe. And we plan to ship the user interface part for Android and GTK Plus, which will run also on Linux and Windows. And of course, you have a server-side and command line interface already. So yes, today you have command line interface, server-side, universal library, iOS, macOS fluffy user interface applications, and tomorrow we plan to add Android fluffy application and Windows Linux fluffy application.
Awesome. Next, do you expect any resistance to current nodes switching to Bfrost?
Oh, I expect that they will not do that for a very, very long time. It's not about being resistant. It's about the architecture of the code that they have. The way, the standards are defined in bolts, which I criticized a lot, it is the same way the code is organized within the existing nodes, with the one exception of C Lightning, which is much better than others in modularity and layerization. But even then, there, it will be really hard to add stuff like even taproot support, not talking about everything that I was describing, because you basically need to rewrite too much of the existing code to get that working.
Yeah, basically this probably addresses also Francisco's question, how the main Lightning implementations devs received the idea that to add Bifrost to their own implementation, but basically you just covered it.
I stopped discussing these questions with the Lightning node developers. The only node developer I'm communicating to for the last 2 years is Christian Decker, and I didn't discuss with him support of Bifrost specifically, but I was talking about more previous parts like RGB and so on. He will be happy to see it, but again, it's about decision making within the block stream and the other priorities. So I do believe that before Bifrost and RGB will get traction, nobody will care about Bifrost and these ideas, and they will just simply ignore that because they have different priorities. When it will take off, they will be in a hurry to implement it, but they will need to spend a lot of time of doing that, at least a year. So I think that for the next 1.5, 2 years at least, LNP node will be the only node supporting Taproot, RGB, Bifrost extension, data propagation, DEX, and many, many other interesting functionality. Which, of course, we as a Pandora Core company, not for-profit entity, not this LNPBP association, will utilize to our own profits as much as we can do by building user consumer-facing solutions on top of Bifrost protocol.
Okay, next. Do you recommend the use of Rust Lightning? For what? So the real question is, do you recommend the use of Rust Lightning? And my additional question to that is, depends on what, probably.
Well, we are not using it.
Implementation.
We are not using it, and if you plan to again use RGB or Bifrost, I can't recommend it because it doesn't support it. And what we found by ourselves, it's easy to write a new implementation from scratch rather than to modify Rust Lightning to support them. So that is probably the most political correct answer to this question.
Okay, next one. What is the risk of keeping all data on Bifrost instead of locally? Just fees or storage? Just fees for storage.
Well, I think you should do both. So you shouldn't delete your local data while keeping them in Bifrost, but you shouldn't just keep your local data locally without storing them in Bifrost, because in this case, if you use both, you will reduce your risks. So if Bifrost will fail, you still have a local data. If your hard drive had burned, you can retrieve the data from Bifrost. So that is recommended scenario.
I will stress about this question. I will stress yet again that this is something that we originally had to imagine for RGB because we have this data outside the global consensus storage. But right now with Bitcoin, this is a very common situation where you have to store something which is separate from your Bitcoin seed. So if you start using Taproot script or updated Lightning channel, your Bitcoin seed will not be a sufficient backup. So right now, the experience for the user experience for typical Bitcoin mobile wallet, for example, is that you keep the seed, then you can destroy your mobile phone, and then you just recover the seed from your backup setup, and then you have your funds again. But with Lightning and with Taproot advanced scripts, that's not the case anymore. You need some external backup, and with RGB is the same. Of course, you can use a centralized service like Dropbox or whatever assuming that you encrypt the client side. But to have a protocol which is inherently peer-to-peer and decentralized like Bitcoin, and having it depending entirely to some kind of centralized cloud backup service, even if encrypted, is ugly. So the idea of Bifrost is nice because it allows you to just store your seed, but also have this kind of decentralized cloud infrastructure that can help you somehow. Not really. I mean, it's not like Storm. It's not completely decentralized, but it's at least a polycentric, seamlessly integrated with different entities that can join and leave at will.
Yeah, correct. Absolutely.
Very good comment. Thank you, Giacomo. Next question. What would be the incentive to run a Bifrost node?
The incentive is that with a Bifrost, you can get much more fees. You can collect much more fees. Because additionally to the routing fees that you earn today, you get more monetization you can by operating a DEX node, by operating a liquidity pool, by operating even simpler things like storing the data backups for RGB, for the state of other channels, for running Watchtower, for just storing general information and answering the queries about existing RGB assets. So probably you get at least 8 or even more than that, like up to 10 more monetization options. So you can earn and stack more sets than today. And I think routing fees are really, really low. The most interesting part is the DEX fees and also data storage fees, because you can do a lot of queries and store a lot of data. You just another hard drive plugged into your Raspberry Pi running the LNP node, and you instantly earn twice or maybe 5 times more. Again, once there will be an adoption of this usage by the network, but you boost not on the percents, but you probably will boost your earnings from the node several-fold time, which is a strong incentive. And on the other side, the adoption of this thing may be driven by the adoption of RGB itself, because once you get RGB working, you have to utilize the Bifrost network and you have to pay for those services to do normal RGB operations. And what we believe that will be boosting RGB adoption, unfortunately, because we believe in Bitcoin, but unfortunately, need of stable coins that protect the merchants from the price volatility of Bitcoin, and stable coins that can be used over the Lightning Network for scalable payments, not waiting for 10-minute confirmation, not paying on-chain fees, will be the main drive for RGB adoption. So once stable coins will be started used for RGB Lightning payments, there will be demand for Bifrost nodes, and those running Bifrost nodes will be able to start earning more times than today with a Lightning node, which will bring the whole thing into the air. Flying, I mean, not exploding, hopefully.
Okay, good. Next question is, what happens if we do not have capacity to receive data locally when we are not using Bifrost? Does the transaction get rejected? So if you don't have the storage locally, as far as I understood, but you want to receive the transaction, what happens?
RGB transaction, I expect.
Yeah, sure.
Well, for Lightning Network part of RGB payments, you don't need to receive data. You already have them locally. That's the way it works. I can go into details, but it will take a long time of technical details. Just believe me for now. And you can verify later by watching existing videos with that explanations. But for on-chain payments, to receive the payment, you will have to accept the consignment, which may be megabytes of size, or maybe in the future for high velocity assets, even hundreds of megabytes. And if you don't have a capacity, you wouldn't lose your assets, the most important. The only thing that you should point existing Bifrost server, which wouldn't be your own, to be an intermediate store for those data. And you will be able to retrieve them later. Of course, in such case, you will have to probably pay to this Bifrost server. But you can add these Bifrost servers into the universal invoice. So you're just not providing your Lightning node endpoint or information about on-chain payment, but also you are able to add into universal invoice the add list of Bifrost servers, which should receive the RGB payment if you're offline or not able to receive it.
So basically, if you are not yourself a Bifrost node, you still would need, in this case, to use some other server, some other Bifrost node as intermediary?
Yes.
Okay.
Yes. How you will incentivize that node to work for you, that's maybe wallet developers will provide this node for free for all wallet users. Or maybe there will be some commercial services. Or maybe you will buy it as a part of Nodal Cloud. We're doing the common solution for that with a Nodal, and so on. There will be multiple options.
Okay. How is the data availability ensured with some or many nodes going offline?
Well, which data availability depends on the kind of data availability. So if you're talking about backing up your data, well, you ensure that by asking more nodes to store your data. You will spend more time, more funds for that. But again, we're talking about sets or millisets. That's not a huge amount of money today. And also, it will be up to you to find the correct balance between managing your risk for the storage and spending money. You can, for instance, set up 3 servers yourself and run them. Again, it still will cost you money. So it will be up to you to find that each one will find his own way and what is the best option for him. As about the public information, like information about RGB assets, that will be propagated and replicated across all Bifrost nodes, at least honest Bifrost nodes in the Lightning Network. So here we have very high tolerance, because until at least one honest Bifrost node is running in the network, you will be able to retrieve the full information about existing RGB assets, metadata, and their issuance and whatever.
Okay, one more.
Which is actually not that critical information, because if you have some of these assets, you will have that information locally as a part of your RGB consignment anyway. You will need this information if you will run something like CoinMarketCap or some kind of public service providing info about what assets do exist in the world today.
Mm-hmm. Will my Citadel beta be back soon, or do you plan to release the first non-beta version on RGB in the end of the year?
Well, exactly, it will be released as a final part of RGB release. This, according to this chart that I was talking about, the release of my Citadel beta will be actually.
Your screen is black right now, just in case.
Oh, as usual. Yeah, so this is the release. So the release of my Citadel beta will be release of RGB protocol. And yes, we expect it to happen in November. Of course, we can do some intermediate version, but we would not like to promise that, because we will do just the fastest as we can to get to this release point on time. And if it will save us time not to release intermediate version, we will probably not be doing that. But I can't say the other way. So if we will see that we need some testing, more testing, we will release some intermediate versions before the release.
Good. There was also one question at the start of our chat. What are the limitations of client-side validation? Maybe you can briefly somehow touch it, but we actually had 2 calls on this issue. Like, each of them was 1 hour long. Just check out the YouTube and the corresponding slides. But Maxim, maybe just a couple of words, some comments?
Yeah, and maybe even Giacomo can, if you'd like to something, because I'm not sure that I will be remembering everything right out of my head. But the main limitation that you have to store your data locally, or organize proper system of backups, which will cost you money and certain efforts. So that is the main core limitation of client-side validation.
Yeah, the back. I would say there are two main limitations of client validation. That's one, so backing up your data, which is not stored on the global consensus, and the necessity to be online in some kind of synchronous way, or to have some kind of delegated entity online for you to receive these external data. So in the on-chain Bitcoin part, you can just generate an address, disappear for 30 years, and come back, and you have been paid every year regularly. In the case of extra blockchain data, you will need somebody to receive and keep. It is still a problem of backing up, but it's a different problem of backing up. It's not about recovery, but it's about being there to collect the data. And again, this is, as I've said several times, this is the same couple of trade-offs that the Lightning Network itself has, just less serious. Because in the Lightning Network before L2, you need to keep your channel updates, but you have to keep them secret because they are toxic waste. In RGB, your state is a privacy problem, but it's not toxic waste. It cannot be used against you without the keys. So it's a problem in Lightning, but less serious. And also in Lightning, you must be online to receive payment, but also to check that the counterparty is not trying to scam you with the previous state. So you also have to be online for a security reason, while in RGB you only have to be online for a receiving capability reason. So you have the same trade-offs of Lightning, but less serious, probably closer to the trade-offs you will have with L2, or even smaller than that.
It's a very good one. Good comment. Thank you. Another question. I think we've answered it like thousands of times already. What happens if the client-side data is lost in the worst-case scenario? Would it affect any smart contract applications?
Yes, it will affect all the smart contracts which were contained in those data. And basically, you will lose access to your assets related to these smart contracts. They will not be stolen. So the owner of the asset is controlled not by client-side data, but by the same private keys which control your Bitcoin addresses. So unless you lose those keys, your assets can't be stolen, but you will lose access to those data. And that's why maintaining a proper backup is a must-have for this case. Hello?
Yeah, you're here. Everything is okay. Thank you. Any more questions, guys? So far, we have. Oh, okay. To come back to the exchange rate, RGB token versus RGB token BTC versus RGB token 1, RGB token 2, the principle of coincidence of ones would point that it would be more efficient and profitable to price anything into the hard money, aka BTC, as you would have more liquidity, and that if you want to go from RGB token 1 to RGB token 2, you would have better offers if you do an indirect exchange through BTC.
Yeah, that's a correct point. Thank you, Trikala. But it's like an economical incentive why there will be much more nodes in BTC to some token liquidity than token to token. But it's not a technical reason. So technically, you may have whatever you want. Economically, you will profit more from having some token to BTC node or BTC to some other token. And but of course there will be some people who are not good at economics trying to run those nodes, so we will probably observe also token to token nodes in a minor proportion. Yeah, and of course arbitrage opportunities, of course, and traders opportunities. So a lot of new interesting things will come when we will be able to finally launch all this huge spaceship into the orbit.
Okay, it's been a while already. Probably we can wrap this up today for today.
Yeah,
Mm-hmm.
yeah.
Maxim,
I would be
thank you very
glad to
much.
have some rest.
Yeah, thank you very much for the talk. Thank you very much for the slide. As soon as the recordings and slides are ready, I will upload all of them to all of the resources that we have, and I'll send the link to the Telegram chat. So be a bit patient. Thank you everyone for joining the call today, for all the questions. If you have more, feel free to drop them to the chat or reach or RC also. We have that channel. So yeah, see you in 2 weeks, I guess. Thank you very much. Have a good evening.
Thank you very much. Thank you all.
Thank you. Bye.
Thank you. Bye.